My name is Caitlin O'Connell-Radwell. I'm on the faculty at the Eden Peabody Lab at Harvard University, and I've been studying elephants for 30 years. And today I'd like to talk to you about how similar elephants are to us, both physically and psychologically, and in their social makeup. Now, we are very similar to elephants socially. There are a couple of developmental differences between us. One, humans have a 9-month gestation versus 22 months gestation in elephants. Humans are born at about 7 pounds versus 250 pounds. And it takes us 12 months to first steps, whereas elephants basically are born to run, hours till running, and 3 to 5 months to rumble. And for humans, it takes about 2 years. So there are those differences. But otherwise, elephants live in tight-knit families. They live within matriarchal extended family groups with a matriarch that leads the way. Now, elephant calves are born into these tight-knit families where the first individual they know and bond with is their mother. So mom is the center of the universe. And up until the age of 1 year old, this baby will fit under mom and often will go underneath mom for protection. Now, once a calf is able to walk, it's soon introduced to the extended family, which can be a very exciting event. But in these events, you will see that just like there's human politics within and between families, elephants have a pecking order within extended families. And you can see the lower ranking family with this blue arrow is heading towards the low quality water in the pan versus the high ranking family is going to head towards the source of the spring. These things have already been worked out ahead of time to minimize conflict over access to this very important resource, water. So high-ranking families head towards the source. As you can see, this big group in the foreground, and then the low-ranking families head to the shallow pan. Coming to the waterhole for a drink provides the elephants with the opportunity to socialize. And this is a very exciting time, especially if there's a baby. So in this situation, the female is introducing her new baby to her mother, who is on the left. And this can be a very vocal time. The ears are flapping, they're rumbling. They're also urinating and defecating, which is a huge jubilant response for elephants. That's a little bit different than ours, but that's, and also you can see this, this black streak on the cheek of the elephant on the right. That's streaming from their temporal gland, which shows heightened excitement. Now, no family reunion would be complete without having a mud bath together. And this is, again, a very exciting time, especially for the little ones. They've been, 24 hours or longer out in the hot, dusty sun, and coming in and playing together in the mud is a very exciting time for them. And sunset is a favorite time. They feel more comfortable moving in the late afternoon to nighttime, and that's probably due to weather, less windy conditions and better conditions for long distance transmission of sound. So the females tend to be more active anywhere from 4 or 5 o'clock in the afternoon into the night. After sunset, dusting is a very important aspect of elephants maintaining their skin. As they leave the waterhole, they're wet, so they dust and then move into the forest. And that dry dust, then they rub off against trees, and that helps rub parasites off. The dust also helps protect their skin from the sun. Now, just like humans, the character of matriarchs can define the mood of the group. So you can have an individual who's very calm and just comes to inspect something new in the environment, or you can have a matriarch that charges first and asks questions later. And that really does affect the confidence of the rest of the group based on how their leader responds to a change in the environment. And just again, as the case with humans, environmental influences affect their social behavior, where individual families, if they're low ranking, they might have to wait at the edge of the clearing of the waterhole for hours until it's safe for them to come forward. Or if they're a dominant family like this family, the scimitars, they'll come barreling in and then push out another family so that they can drink. So there's a lot of politics that go on at the waterhole. And then, of course, there's politics within families. So high-ranking females, the calves of those individuals, we have observed that they have social privileges. So they're given leeway, they can run farther away from mom and get themselves into trouble without being reprimanded as a lower ranking individual does. So this is very similar to our society. Now, high-ranking calves can also, if they approach a low-ranking individual, their mothers could stop them from interacting with a low-ranking individual. And this is not something that people normally think about in elephants. And we think that it's partly because our population is a desert population. And so water is at a premium. And we think that we're seeing different cultural changes based on this very, very restricted environment, such that the high-ranking individuals are more defined than they are in groups where resources are ubiquitous. So we're seeing these very distinctive treatment towards the calves of lower-ranking moms. And why we think that is the case is because a family group has to stay very small when resources are limited. And so we think that the low-ranking individuals are being pushed out of the family to start their own family, because the matriarch of the larger family, it's really hard to move through the environment and feed that many more individuals. So we're measuring this behaviorally and showing that there's this harsh decision that families have to make as to who gets to stay and who gets cut. But within the family, daughters, cousins, sisters, they stay together for life, and they become moms together, they raise their young together, they become grandmothers, they become great-great-grandmothers. And for males, this could also be the case once they leave their family as teens. They could meet up in the future and become very bonded for life after having been raised in a family together. Now, just as it is for us, ritual greetings are very important to elephants, and they're also learned at a very young age. So ritual greetings evolved in elephants from the concept of having to learn what's safe to eat from others. So younger individuals will approach older individuals that are eating, place their trunk in their mouth, and learn, okay, that food is safe to eat. Well, that simple behavior has been ritualized into this greeting, what's called a trunk-to-mouth greeting, where the one individual approaches another and places their very delicate trunk in the mouth of another, which obviously is the sign of trust between those individuals. So greetings can take the form of a reverent salute for one individual that is particularly attractive to others. The young bulls, when they see this older individual, they get very excited and they want to quickly place their trunk in his mouth first, whereas elders need to wait in line and place their trunk in the mouth and then step back, and then the next one comes along and places the trunk in the mouth. Very similar to our kissing of the ring in leaders. So it's kind of fascinating how very similar our rituals are. Now, teamwork is important to elephants. This is a young matriarch showing very young females how to extract a calf who is stuck in the well. Now, this teamwork requires a lot of coordination. If two individuals are not that coordinated, as you saw in the last slide, that young female pretty much showed the rest of them how to do this. Whereas when there's two very coordinated individuals, like Big Mama on the left and her daughter Nandi, they don't have to organize, they don't have to coordinate, they just do it. They get down on their knees and get that individual to safety. And that takes a lot of relationship building in the background in order for that to happen. Now, then there's other creative solutions where this little preemie, she was born a little premature, she's very wobbly, gets to the waterhole, sees everyone else placing their trunk in the water, really curious, so she starts to explore this. And sure enough, she falls in with mom's trunk right there. Constant oversight, sees that her little baby female calf has fallen into the water. And these calves are so heavy, they're very dense. So it's a risky time for these little newborns. And so mom doesn't want to take her trunk and lift her out of the water because she's worried about how fragile this baby is. So she comes up with a really unique solution that I had never seen before. She starts blowing bubbles underneath the baby in order to raise her to the surface so that she can scoop her out. And that's exactly what she does. She floats her up, and then she's able to pull her out to safety. Now, there's many rituals surrounding other aspects of life, and one of them that's very important to young elephants is play. And play has a ritual invitation where an individual places their trunk over or on top of the head of the other individual. Now, later in life, this could be also a sign of dominance, but at this age, or when two males are playing, this is also, come on, let's play. I'm going to put my trunk on your head. Now, this play for these youngsters also can involve the oversight of an older sister sometimes, usually around a 6-year-old. She'll be watching out for these little play bouts and making sure that they don't get too rough, because their favorite thing to do is pig pile, as you can see here. Now, as the males get older, these invitations are similar, placing the trunk over the head, but they get more intense. The play bouts are much more intense, much more forceful, until even later, when two older bulls get together, and they're bonded, they will have this kind of gentle sparring back and forth, which is a very bonded behavior. And very different than the combat that I'll show you later on. And it's also very similar to our own jousting or martial arts. Now, hormones and the coming of age itch is very evident for young males. They take risks much more and much earlier than females. Females tend to stay much closer to mom and to other family members, whereas the little males want to go out and just explore the world, and that can get them into trouble because they can't resist chasing everything that they can in the environment, and that continues for some time, and even to the point of passing along this bad habit to a baby brother, as is the case here. With Leo and Liam teaching his baby brother how to chase a giraffe because it's a fun game for them. Now, these young bulls become kind of problematic for moms when they just have a new baby. This is Liza, a new baby, and mom Winona has had enough of her older brother's attentions because they could become dangerous. He places his whole heavy trunk on top of her. Even though he's teasing, he's excited to have her in the family. Mom thinks he's just a little too attentive, and it's time to give him a big trunk slap to stay away from baby. Now, in some years when there's a lot of babies, this causes moms, this is the oldest son, where he is just a little bit taller than her, so it's hard for her to push him out of the family. Now, this when males come of age between 12 and 15, they want their freedom. They start to explore their freedom and independence, but it's also kind of a push me, pull you situation where they want their freedom, but they don't necessarily want to go out and be on their own in the wild. And so it comes to a head when there's a lot of new babies born. It's time for moms to push these individuals out of the family. And that means that we get a lot more young bulls in the population alone, having grown up in family, and now they're looking to see how they can integrate into the male social structure. So sometimes they don't want to leave at all, and at the waterhole, a female has to chase them to the point of him dropping his drink and her giving him good tusking on his behind to say, look, this is time. It's time for you to leave the family. Now, for an adult male, they often don't cross paths with females. The males tend to spend a lot of time at the waterhole during the day, whereas the females, as I said earlier, feel much more secure at sunset and after dark, where sound transmission is much better. They can keep tabs on each other from longer distances away, and they feel comfortable coming in at that time. So males don't normally interact with the females unless there's a female coming into estrus and a male is coming into the hormonal state of must and is interested in mating. Otherwise, there are a few occasions where a favorite bull, the females like to interact with him, and he might stay on and interact with them, possibly because he grew up in that family or just to say hello. But when a young male leaves that security of family, they are looking for older bulls because they're social animals. They don't want to be on their own. And this is a very vulnerable time for them. They're vulnerable to lion predation, and a lot of older bulls don't necessarily want to take on these youngsters because that means they have to share their resources with them. So finding mentors for these young bulls is very important, and sometimes very dangerous if they approach a bull that it has no interest in them. But there are some older bulls that really actually enjoy taking in these youngsters and welcome the company. Now here is a group of individuals that I've been studying for years and trying to understand a dominance hierarchy where Greg, number 22, is the dominant bull, and this is part of his posse, all of these individuals. And at this point, I'm going to show you how you tell elephants apart so that when I take you out on safari in the next few minutes, you'll be able to have a little more orientation to these animals. So the defining features, their ears are very helpful in identifying them because there are natural wear and tear that goes on the sides of the ears, and more extreme in this case. So they all have numbers, but they also have names. This is Willie Nelson because of his raggedy ear and raggedy long tail. This is Gakulu because he's a very large bull, and this is Greg, our dominant bull. And these little ear tabs here, we did not put those in there. Those are natural. What happens is that little hole occurs when a parasite insists on the edge of the ear. And then that parasite drops out and creates this hole here. And then that hole gets pulled out into these patterns. So that's a very distinctive pattern for Greg. And then others have distinctive patterns. There's hair length and hair shape on the tail that are very important features. Tusk shape can be very important from year to year. They do break their tusks in this natural desert environment. There's a nutrition deficiency in the soil, and so the tusks tend to be more brittle, and so the more aggressive bulls tend to break them more. So that is another indication. Body size, penis coloration is also an interesting component of our bull ID book because there are different gradations of pink colors versus black on the penis. The skull and ear shape are also important. Now here's a situation where if you were presented with all of these different bulls, I'm showing you their defining feature. So Greg has these tabs and a hole in his left ear as he's facing you, his left ear. And then Rodwell here has this very deep crescent, a tab, and a hole inside the crescent. Whereas Tim over here has a crescent, he has a hole in front rather than inside the crescent, and also a tab. So these two individuals are very similar, but there are important differences, and that helps us define these individuals. Smokey here has this lovely scalloped ear along the right edge of his ear. Now Luke here is missing his right sword hand, which is why we call him Luke Skywalker. And Torn Trunk has the tip of his trunk torn off. So he's very definitive. If you can see his front side, he's definitive, which is why tails are important, because they often show you only their back sides. And then Keith here has a little tiny C cut out of the middle of his left ear. So now, if you were just to see these images and can pick out, I'm going to give you a little quiz here. If you can pick out an elephant that walks by with one of these features, this is Smokey's scalloped ear, this is Tim's crescent with hole and tab, this is Keith with a tiny cutout, this is Torn Trunk, this is Rodwell with a deeper crescent, tab, and the hole on the inside of the crescent as opposed to in the front of the crescent. This is Greg with his tabs, and this is Luke without his missing right sword hand. So here's an elephant walking past. You see the scallop, tab, and hole in front as opposed to on the inside. So if you can tell me who that elephant is, you can come join me in Africa right now. We're going to go on safari. I'm going to take you to our field site where I've been studying elephants for 30 years in Etosha National Park, Namibia. Namibia is on the southwest coast of Africa, and the park is in the north central region. It is a dry, ancient lake bed, and our field site is closed off to the public, Mashara Waterhole in the northeast corner. This is what it looks like on a satellite image. You can see the Etosha Pan from far away. And then you can start to see our field site here. There's only 3 waterholes in the whole region, and this is our camp and waterhole. This is what it looks like from a drone's eye view. Here's our camp setup. We are looking at this waterhole and measuring dominance along the pan, because elephants like to drink from the freshest source of water, so the more dominant individuals are going to be occupying the head of the source, and then the lesser dominant individuals, the lower ranking individuals, will be drinking from the pan. And here we are in the observation tower doing our measurements and recording behavior. And this is the camp setup that we set it up every year. It's a temporary camp. It's all solar powered, so all of our video and computer equipment on the research level is charged from the solar panel. We also have a small fridge in the kitchen that is charged off the solar panel. So everything we do is off-grid. Now here is an example of a day in the life of Mashara, where you are seeing the world go by, as opposed to on a normal safari where you're driving through the environment. Here the safari comes to you and you get to see the patterns in nature. When the giraffe come in, when the elephants come in, mostly bulls during the day, and as the sun started to go down, you'll see family groups throughout the night. Now here's an example, if you follow along the month, of what it looks like throughout the year in our camera trap data. How many elephants there are during any one season. You start to see clouds building in November, December, then green, it's all green, and then elephants move out of the region because they can eat and drink other places, and then right back to June, where there were, between April and June, there was no elephants there, so it jumped from April to June. So what happens is that there's a lot of water and water availability elsewhere, and so the elephants had been eating all around this area in the dry season. So once there's rain, it's a big relief. They can go further away and eat better quality food further away and then come back again in the dry season. Okay, now I'm going to show you a little bit of elephant behavior and just how subtle these behaviors can be. But in this case, this is all-out combat. This is a very dangerous situation where two bulls are clashing face to face. They have to square off, and if they don't square off, that tusk could go straight into their flank and could inflict a mortal wound. So this would be considered combat. Now, this is a very much more subtle situation where this young bull would like to drink at the head of the spring because the dominant bull is not. So he figures, well, why not? I get to have some better water because he's down there. But the dominant bull says, no, no, under no circumstances am I going to give you the dominant position. And it's very similar in humans. As soon as you give a little leeway to that teenage boy, you're gonna pay for it. And so dominant bulls know this, and they are very vigilant about keeping up that dominance, even if they don't feel like drinking from that spot. So those are some of the subtleties that one has to be aware of when they go out and measure behavior in a intelligent animal. Okay, so here's an even more subtle situation. Here's a much older bull stoley. Here's Jack. He's just like a young teen, getting his driver's license, wants to get the keys to the car from dad. He's taking his trunk, putting it in the best water, and the older bull saying, no, I don't think so. He's pushing him away. And Jack continues. He's very persistent. Got to get his trunk into the head of the trough, because that means that he's pushing his dominance. And the older bull decides, well, I'll just use you as a scratching pole to distract you from your goal. And this is just an example of how older bulls are really important regulators in the population. This comic is just to show you that elephant behaviors can also be interested. They're influenced by many factors. Whoever's at the waterhole, who's dominant, who is subordinate, and it also complicates the situation that they have self-awareness. Now, this has been determined by what's called the mirror test, and the mirror test indicates that an intelligent animal can understand that when they look in the mirror, they're seeing themselves instead of someone else. And this is done by placing a white dot on the forehead and seeing if an individual will inspect that dot as being something new to their own appearance. And that's what the mirror test is, and the elephants have passed that. So yes, they are self-aware, and that makes things all the more complicated for a behaviorist trying to measure behavior. So the next segment I'm going to talk to you about is how elephants keep tabs on each other. It's very important that they stay together, but when they're foraging out in the environment, and they're better off if they can move far away from each other to be able to reach the best food. So in order to keep in touch with each other, they have what's called a contact rumble. It's a very low frequency rumble that is played. The males have this very low frequency, 10 hertz fundamental frequency in their vocalization, whereas the females, because they're smaller, their fundamental frequency is at 20 hertz. And here you'll see this is a male versus the females, and you can see that he's at least a third or more larger than the females. So they're able to create a vocalization of 10 hertz rather than 20. And this vocalization can be heard at a distance, and I'm going to play it for you. It's very soft. It sounds kind of like a truck rumble. So what we're hearing from that vocalization is the higher harmonics here. We can't hear that 10 hertz harmonic. Our threshold is 20, but really operationally it's 30 to 40 for most people, especially in a noisy environment. But these vocalizations propagate long distances. These 10 and 20 hertz signals, even at 50 meters, you can see a lot of the higher harmonics have dissipated. And then 500 meters and at 800 meters, you only have the first two harmonics. And then once you get past a kilometer and several kilometers, you're really only talking about that one fundamental frequency. And in elephants, it's very monotonic, it's very flat. And if you think of an arrow and throwing an arrow through space, you'll get much further distance from that arrow if it's long and flat rather than if it had arches in it. And elephants, when they are agitated or some heightened emotion, then they put more rise and fall of pitch into their vocalization. But just a straight contact call would be flat. Now, while these elephants are vocalizing in this very low frequency rumble, it's made at a sound pressure level that's like a mini explosion. It's made at 120 decibels. And these elephants can detect those vibrations through their very sensitive trunk and their feet. And we set out to show this. Now, let me just point out that many animals use vibrations to communicate, including humans. Your vibration setting on your cell phone, for example, that's a modern example, but throughout history, people have used low frequency drums played on the ground to communicate to the next village, and many other animals use vibrations. Now, vibrations in nature, I think many people are aware of the Rayleigh waves that are the very high amplitude signals that break up parking lots and bridges during an earthquake, where most seismologists are looking for that P wave, and they're trying to get rid of all of this noise. So we haven't really paid attention to what happens on the surface of the earth and how far these signals can travel, because we're busy trying to measure earthquakes and gas, oil exploration, and getting rid of these Rayleigh waves. But animals, these Rayleigh waves are very important. And they are detectable through vibration-sensitive cells called Pacinian corpuscles. So all mammals have Pacinian corpuscles, and they act like an onion. There's many layers, and there's a nerve impulse, a nerve fiber in the middle of those layers, and I'll show you what they look like. But basically, as all the layers shift, a nerve impulse is sent from that vibration. So here's the inside of an elephant foot, and you can see these Pacinian corpuscles with all of the layers, and these layers shift during a vibration and send an impulse, send a signal to the brain. So that's one way, one pathway that elephants can detect vibrations, but they can also detect them through bone conduction. And again, we can do this as well. So all mammals have 3 middle ear bones, and the very large malleus that the elephants have is indicative of bone conduction hearing and vibration detection. And this is all going to become relevant at the end of my talk when I talk about human medicine and what we can learn from elephant bone conduction hearing applied to humans. But let's go out and play back one of these signals, a signal that elephants use that's important to them, play it back through the ground and understand how exactly are they detecting these signals and how are they discriminating between signals. So here we place shakers in the ground that will deliver the signal. We have a speaker that we use as a control and play back the sounds through the air as well as the ground. And then we have sensors both in the ground and in the air to know what signal we're delivering and to make sure that the signal's not coupling with the air and it's actually a signal in the ground. So after we have all of our equipment set up, we want to play something through the ground that we know will have an impact. And many years ago, when I worked for the Namibian government, I was trying to help farmers keep elephants out of their cornfields. And so I was looking for elephant vocalizations that might deter them from coming into an area, which was better than what people were doing using shotguns, and basically it was not an ideal situation. So I was trying to minimize conflict, and I was looking for different vocalizations that they might be either attracted to or deterred from. And I have recorded a number of vocalizations in the wild, this one being one of them, where it's this vocalization is being made in the context of lions hunting, and the matriarch is warning the family that they're in danger. And so I'm going to play this back in the air to show you what happens if I were to play it back to a group of elephants. and then we will play that back through the ground. So right now, I am broadcasting it to this group of elephants after they drink, after they settle down, to see if a farmer might be able to use this to discourage elephants from entering their fields. So here is what happens when I play it back through a little boom box in a bunker. So as you can see, this vocalization has a very large impact on this group of elephants. So I did not take this lightly by playing it. I made sure that everyone had their fill of drink. I was surprised to get such a strong response. But we used that knowledge of this, and it's really these three particular vocalizations that caused this concern. The matriarch came forward. While everyone else was still drinking, she came forward, she inspected, and then she made the decision and they all left. Now, in this situation, we play back that same signal through the ground, through shakers in the ground. We wait a requisite period of time that the observers don't know what the time regime is. And then once we play it back, we get this group freezing behavior, and the source is right over here. And then what they do is they bunch up into their tighter family groups, is how they feel much more protected when they're wary. So we played this back in a number of different scenarios and showed that they, in fact, were detecting these signals through the ground. And not only that, they were detecting differences in whether the anti-predator call was made from a group that they might have experienced versus a group from another country. They would respond much more strongly to a local resident group. Now, we also wanted to understand, okay, if they can detect these signals in both the air and the ground, when would they choose one versus the other? And we had this opportunity to play back estrus calls to musk bulls, partly because musk bulls, they search far and wide for a female on estrus, and sometimes they'll go outside of the park and cause trouble. And it's very difficult to get these bulls back into the park because they're pumped up on testosterone, they have very erratic behavior. And so we realized in the course of our basic research that we had a conservation application on our hands. We could actually invite that bull back into the park in a very specific way. So I'm going to play back this estrus call to this musk bull, and you can see that he's using both his ears to orient, but then also the ground, and then he turns and faces the source and follows the source. So he scans with his ear, places his trunk on the ground, and he walks right past this pile of sticks, which is where his lovely female on estrus is hiding. And he goes out to the edge of the clearing, and then we will play the call back again at the edge of the clearing to make sure that we're the ones that are causing this. So as you can see, these vocalizations can be a very powerful tool for both conservation and for understanding how an elephant is perceiving these signals. Now, the other thing that we learned by putting our geophones out there across an elephant pathway is that each elephant all of the species that we measured have a very different signature as they walk on the ground. And we measured these for a whole group of elephants, for individual elephants, and then for different species. So you can kind of hear a thunderous So that's the noise of a whole elephant group moving across the sensor. So from this data, this is another conservation application of our research, that elephants and other large mammals could be documented based on their footfall patterns coming into a waterhole. So we could census the waterholes remotely. We could also detect where there's human activity that shouldn't be there. And that's just another Our next conservation outcome was we gave a captive elephant a hearing exam through her feet, because we wanted to know, we understand how the signal is now propagating in the ground, how far it might travel, but what we don't understand is how an elephant might be able to detect these signals from how far away. So that means, how sensitive are the bottom of her feet? And basically we designed a hearing exam to ask her that question. And from that, we realized, well, if we can ask her that question, we can ask her other questions and really get at this understanding of long-term memory. With elephants, we always say elephants never forget, and we know that they have these migratory paths that they follow from year to year, but how exactly are they doing this? And so we devised an experiment to show that an elephant can see an object and form a representation of that object in her mind. And if she can do that, that means she can make plans about that object. Let's say a marula tree that she loves along a certain migratory path. If she can imagine that in her mind, she can make plans to go to that place. And so our first step towards showing this is to show that Donna, the elephant, will be presented with a real banana and then choose the picture of the banana versus a blank. Now, this is her first experiment, so she's not perfect at it, but you get the understanding of how she can undertake this task. So Gina is holding a banana up. She goes and touches the banana picture and then gets a treat. And then she's asked to start the experiment again by placing her trunk on the target. She makes a mistake and goes to the blank. So the banana is removed, and then the banana is returned again, and she goes and touches the banana. So these are other examples of how we can learn more about elephant intelligence through these kinds of experiments. Now I'm going to move a little bit to specific conservation issues in a country like Namibia, where I have been working for 30 years. So elephants in Namibia live in many different environments, just like humans do. And so in the desert, in the scrub desert, in the riverine habitats, elephants and humans, they compete for food, water, and space. And so how do we address this? I was an elephant scientist for the Namibian Ministry of Environment and Tourism from 1992 to 95, and ever since I've been working with the communities. Here I am in a field with my ranger colleague, visiting a family whose crop was eaten all in one night. The elephants sneak in, these are elephant footprints, into the crop, and if it's a whole family especially, they can destroy the whole crop in one night. So people are not happy about that. And if we want to keep elephants around, we need to figure out how to mitigate these kinds of conflicts. And here are some of the other issues going on. The elephant-human interface is expanding in Namibia, which is a good thing, but it also means the scope of the elephant-human conflict is also increasing. Partly another problem is habitat loss in key elephant areas, which means their migration routes are being threatened. And then the potential for poaching in some areas requires a lot of policing and vigilance. Here's a quick summary of the elephant status based on the African survey in 2014, showing that populations declined by 30% between 2007 and 2014. So elephants really need our help and the future generation to think about how to solve some of these problems. Now I'm going to move a few minutes into addressing human medicine and how elephants might help us create a better hearing aid. And why I'm interested in elephants in a medical school department is because of this area right here. They're much more sensitive to these low regions, and they're much better at detecting bone conduction than humans are. So we're figuring out, well, what can we do to simulate that in humans? And here's just a quick graph to show the green is elephants. This is how much more sensitive elephants are to bone conduction than humans. And so what we do is we put motion capture targets on the middle ear bones, deliver a sound through the middle ear, and then watch how the elephant ossicles move as opposed to the human ossicles. And we try and figure out, well, what is it that's different that creates so much more sensitivity for the elephants? Is it mass? Is it the articulation of the joints? And so these are some of the things that I'm looking at Harvard Medical School to see if we can create a better bone conduction hearing aid. So in conclusion, the knowledge of our similarities with elephants, both physically and psychologically, are quite humbling if you think about how our societies are so similar politically, how we care for each other, how we treat our elders. But that knowledge can also inform conservation and human medicine. And here's some of the outreach that I've done, writing books, both nonfiction books about elephants and also fictional books about the ivory trade based on my experiences of watching the town doctor being chased by my boss in Namibia, and also going into China and seeing what the issues are there. My latest book that's coming out in January, Wild Rituals, is a book that shows how our rituals are so similar to other animals, and to see how important these rituals are to other animals is a reminder of how important they should be for us. My charge to you is to help inform your community as to how important elephants and other species are to this world. And we offer different events at local museums, wineries, galleries to help get the word out on how important these animals are. We also have a donor volunteer program where you can come and learn firsthand about our elephant field site and the individual elephants that inhabit that area. Here's a little bit of our funding. I'm currently funded by the National Institutes of Health, National Geographic Society, and a number of other organizations. And with that, I'd like to thank you for your attention, and I look forward to having a discussion with you of any questions that you might have. Hi, I've enjoyed the lecture. I have a number of questions from you here. The first question is, what makes one family low or high ranking? And that's a very good question. We are actually in the middle of studying that. In terms of between families, there seems to be this seniority, whether it's based on legacy, how long the family has been in the region. It also appears to be based on aggression and how successful one family can push out another family. And these aggressive behaviors you don't normally associate with elephants, but we see aggression a lot based on access to resources, and because we're in a desert environment. And I do think that elephants are culturally different in these different environments where water is ubiquitous. Say in some of the areas in Kenya, you don't have so much aggression between families as you do in a desert environment. What we're trying to measure within families is in a large extended family, how is dominance decided? How is a low-ranking female decided? And I think it might be based on bloodlines. So in areas where water is ubiquitous, again, it's believed that the next oldest, wisest female becomes the matriarch. Well, for us, it looks like bloodline is a contributing factor for who becomes the next matriarch, which is interesting. And I think it has to do with what's called optimal foraging theory, where you have a minimum size group that can move across an environment and feed, but the matriarch seems to know, or it's instinctual, that if you have 50 elephants moving across the landscape, it's harder to feed them all than if you only have 20 animals. Now, once your family gets really large, they have to make hard decisions about how they're going to keep the family size smaller. And so we think that it's based on that low-ranking female is based on the furthest away from the matriarch's bloodline is the one that gets pushed out. Now, that's our hypothesis. It's a working hypothesis, and we're trying to understand if that's how these choices are made. It's a very hard choice. It's kind of like that, what the life raft question. Who are you going to keep in your life raft? Your immediate family, the whole community? You know, it comes down to these very hard choices. And I could spend more time on that, but we're going to go to the next question. My daughter wants to go into animal behavior studies and research for a career. I'm sure many of you have family members that are interested in this line of research. Do you have any recommendation on schools or degree programs to go into for animal behavior research? Well, for me, I went to University of California, Davis. It has a big animal behavior program and also ecology program. There are a number of really good programs around the country. It's mostly for graduate school. You have to find a researcher that you're interested in and approach them and have a discussion with them about the program and if that researcher has room in their lab. It's a whole process where I highly encourage volunteering on animal behavior projects, getting experience, and then people are more likely to take someone on. But I highly recommend doing that. Okay, so the next question, how do we tell the difference between African and Asian elephants? Well, that's very interesting. The Asian elephant actually evolved in Africa with the African elephant and then migrated across the land bridge to Asia. And that original species went extinct in Africa because of the drying of the more jungle-like habitats in Africa. It got drier and drier. More open savanna areas were more conducive to the Loxodonta africana, which is the savanna elephant, versus the Elephas maximus, which is the Asian elephant. And just telling you that as interesting evolution. But when you look at the two of them, the Asian elephant evolved in a forested environment, and that's partly why their ears are so much smaller. So as a big African elephant, savanna elephant, opens and closes their ears, that allows a lot of blood flow through the ears and it cools the elephant. Whereas the Asian elephant is not in such hot environments, they're in the cooler jungle. When they flap their ears, much less blood is flowing through, but they don't need to cool as much as the African elephant because they're smaller and they're not in such a hot environment. That's the main difference when you look at the two elephants. The other main difference when you look at them is the Asian elephant has more of a humpback, like a camel, versus the African elephant has more of a saddleback. And that's something you can see from a distance too, and the Asian elephant is smaller. It looks more like the mammoth than the African elephant. You can also tell there's other differences. There's one tip on the Asian elephant on the end of the trunk versus the two, what's called a finger. On the African elephant's got two. There's a toenail difference between them, but the main differences are the ears and the saddleback. And the reason for that ear difference is because of the environments that these two species evolved in. They also have a much lower frequency. The Asian elephant has less harmonics in their vocalizations, as I showed you that picture of the harmonics of an elephant rumble. The Asian elephant doesn't have as many harmonics, and we think it's because they evolved in a jungle, and all of that harmonic noise would be attenuated by the jungle, by the vegetation, whereas the African elephant is vocalizing more in an open environment. And so those higher harmonics can travel some distance, not that far as you saw, but still there's information there. Okay, so I'm going to move on to the next question. How do you recognize males from female elephants? Males do not have visible testes. This is the question, and that's correct. Males have internal testes, so you can't look from the back and see that aspect of the elephant. Main differences between male and female: if you have a comparison, the male is much bigger, a third to two-thirds size bigger. Main difference if you don't have a comparison is that the head of the male elephant is more rounded, and the female, so if you're looking at the side, the forehead is more round and broad. The female from the side is more pointed. Her forehead is more pointed and it's more narrow. That's one main difference. If the male drops his penis, which they often do in supplication, penis signaling is very important in male elephants, they have a very large prehensile penis, and that's very obvious if it's available for you to see, so there's no doubt about it then. But when he has it retracted, the main difference again is this forehead. It's rounded, and also the tusks are much thicker in the male elephant versus the female. The female tusks are more slender, not as wide splayed mostly, and the males, the tusks are much fatter. Those are the main differences. I'm trying to get through all of these questions because we don't have that much time left. Another question: how many herds have you been able to study, and how are they tagged for future reference? In our area, the region where I do my research, is about 300 elephants. There's, on average 10 families and about 200 males that we follow. The families, we don't tag them, as I mentioned. They have natural distinctive features that we look at, and so we watch them from year to year and through camera trap data. And when a new family comes into the region for whatever reason, from drought or flooding, then we start monitoring that new family. So we have about 10 family groups that we monitor and have been monitoring. Again, I've been out there for 30 years now, so some of these families we've been watching for a very long time. So what do elephants eat? Well, in the dry season, they eat mostly branches, pods, parts of trees. And in the wet season, when there's grass, they will eat a lot of grass and fruit. And they have very specific trees that they eat. And I mentioned in my lecture that they actually have to learn what to eat from family members. So the young ones will follow and learn which species is safe to eat. Mostly acacias are their favorites. There's a lot of acacia species, and then some others. Silver terminalia is one of them. So let's see. Do elephants have good memory? That's another question that we're trying to quantify exactly how good their memory is. And it's now, we've run out of time. I did talk about memory a little bit. They do have very good long-term memory, but we're trying to really understand how it works. But I'm sorry, we're out of time. I hope you enjoyed learning about elephants. And there's some information about our website, about our nonprofit, if you'd like to learn more or have, host your own elephant lecture. Get in touch with me, and thank you very much for your attention.